This is problem number 10 from chapter 12. We have a small data set here and we have several questions to answer. First one says to complete the above table for the cost per ounce of the different values or different sizes. We have $3.99 for 16 ounces, and the cost per ounce would be $3.99 divided by 16. And so if we have a set of data like this, we can do this all in one shot using lists in our calculator, and since we're going to need to put this into data in our calculator anyways, we might as well do it all here. We're going to go to the lists editor, and I've already listed my sizes and my costs in L1 and L2, and so for my L3 I have some data here that I want to get rid of, and so I'm going to arrow up to L3, and so my editor down here says L3 without a parentheses equals to a list of things with the curly braces, and I just want to clear that out. So I'll press clear and I'll press enter, and that's gone. So now I want to go back up there. I notice that this is L3 parentheses 1, which means I can put data in here if I want, but I want to go all the way up to L3, and then I'm going to do this calculation all at once. I have my L2 list, so I'm going to type L2 and I want to divide it by my L1 list, my L1. So L2 divided by L1 would give me a term by term division for these list elements. And so if I press enter, I'm going to get my solutions, my answer. So let's put in some values here. We got 0.249, 0.15659, 0.0935, that's for 0.0549. So these are the values that we're looking for. Part B, use size as the independent variable, so that would be your X variable, and the cost per ounce as your dependent variable, or your Y variable, to create a scatter plot. So we're going to again use our calculator for this. Second function in stat plot, and what we're going to do is if you have any of these plots turned on, you can turn them all off first, or if you know how to manipulate things, you can just go to each one and turn them off or on as needed. I'm going to select one. It's already on. If it's not on, and the off would be highlighted, so let's go back and turn that on. Arrow down to the type. The type is a scatter plot, and that's the first choice, scatter plot. Arrow down, you get your X list is in L1, and your Y list is, you might say L2 in your calculator, so you just want to make sure you press L3 for our particular problem. The mark that we'll use would be this square, and that's visually the most the best choice. So I'm going to go to y equals 2, because sometimes, oops, that's not going to work like that. Let's quit out of here, and I'm going to hit the y equals 2 button over here, and sometimes you have some stuff in here that might not be good or might not be necessary for your plot, so we want to make sure we clear everything out in the beginning. Alright, so now to get the scatter plot, we go to zoom and scroll down to the choice that says zoom stat. It's usually number 9, and so if you know that it's number 9, you just click on the number 9 and then it'll automatically do that for you. So here is our scatter plot. We'll put it up here. Well, we can't put it up there apparently. So here's our scatter plot, and does it appear that there's a relationship between the variables? It looks like there's some relationship between the variables. Unfortunately, the relationship that we're looking for does not look linear. It looks like there's a nice, this is called an exponential function, and decay as a matter of fact. It looks like there's a nice function that would fit it, but in terms of a line, I don't know about that. Looks like it might fit this way, it might fit this way. So does there appear to be, from inspection, that there's a relationship? I would say maybe yes. So it's a decreasing relationship. Now, whether this relationship is linear is yet to be determined, and that's what we'll do in the next couple of problems. It says to calculate the least squares line, put the equation in the form of y hat equals a plus bx. Well, we also have a calculator command for that. Let's go to stat and tests. And I'm going to scroll up to get to linreg t-test, which is our most important formula in this chapter, or calculator command. My x list is in L1, my y list is in L3. Your frequency is going to be 1. Now, if this does not say 1, it should, but if it doesn't say 1, this is blinking A, which means it's set to alpha, and if you press 1, you're actually not going to get the 1, but the Y, the letter Y. So to get 1, make sure you undo the alpha by hitting this button over here, the alpha button. So now it's just blinking regular black, and then you hit that number 1. For our linreg t-test in our class, we're always going to be selecting this, and we'll see that in the next problem when we take a look at the correlation. But as a hypothesis test, it's always going to be rho equals to and not equals to 0. The reg EQ here, most of the times if you're just using this for the first time, your reg EQ might have nothing there. I highly suggest that you put your reg EQ into y1 variable. And to get that y1 variable, make sure your cursor is here next to the reg EQ regression equation, that's what it means. Go to vars, right arrow to y vars, select number 1 for function, and select y1. And so now your reg EQ is y1, and from now on, unless you delete it, this y1 will always be there in your calculator. So let's hit calculate. And this is a linreg t-test. It gives the equation form and then some of the parameters for your hypothesis test. I just hit the down arrow one time so I can capture my A and B in this form. Now it says here y, but the notation in the book that they want us to use is y hat. So for letter D, we're going to say y hat is equal to, and then your A value is 0.202, 0.2024 maybe, and your B value is negative 8.194, and then there's e to the negative 4, so that takes a decimal place and moves it over 4 times. So we'll start off with a negative 0.0008. So that's your A plus your B times your X. Now your X is just going to be your X, so we'll just leave it as X. So for part E, it's asking us if find the correlation and to check if it's significant. So let's actually do the hypothesis test to answer this question of significance. So the hypothesis test requires us to have a null and an alternative hypothesis. And so your null hypothesis, if you remember, is a rho equal to 0. This, by the way, means no correlation. And your rho not equal to 0, which has correlation. So rho is the correlation coefficient for your population that you're testing, and that goes from -1 to 1. It's a value from -1 to 1. The closer you are to 1, the more correlation you have. So the closer you are to 1, the farther you are away from 0. And so that's why the alternative hypothesis is the hypothesis that has correlation. Well, in our LinReg t-test over here, if you arrow down, the very last option is your R, and that is in fact your correlation coefficient. So that's negative 0.8088. Let's call it 8.88, your correlation coefficient. Let's scroll back up. And scrolling back up, we have our t and our p-value. So in terms of the hypothesis test, your p-value is what's important. And your p-value in this case is bigger than 0.05, your significance level. So when your p-value is bigger than that, we fail to reject the null hypothesis. And when we fail to reject the null hypothesis, we stick with no correlation. And let's call it no significant correlation. So this is an important result to say that there's no correlation. And part of the issue with this particular data set is that, well, first of all, it looks like it's curved like this. The other part is that there's only 4 numbers we're dealing with. And so the less numbers you have, the more linear it has to be to get correlation. So, so that would be part E. Let's put a box around here to keep in mind our correlation coefficient. Now, F and G, I may have to disagree with the way they're approaching this in the book. It says if the laundry detergent were sold in 40-ounce sizes, find the estimated cost per ounce. And then for H, they say use the points that you found here to plot the least squares line on your graph. So the reason why I don't like this problem is that it's assuming that the least squares line, this line right here, should be used to estimate the cost per ounce. The issue that I have here is that this particular set has no significant correlation, and when you have no significant correlation, you really should not be using the least squares line. Because there's no correlation. If there was correlation, yes, that's perfectly fine, but if there wasn't, then really you shouldn't be using this. Anyways, let's do it the way they're approaching it, and that is to put the ounce size, the size, into X and then getting a Y hat. So let's use a different color for this. For F, so 40 ounces, we want to get the cost per ounce to equal to 0.2024 plus negative 0.0008x. Well, instead of x, you actually will be putting in this 40 ounces. And then likewise for the next problem, we're putting in 90 ounces. Now, we can just punch these numbers in the way they are on your calculator. Easy enough to do. Let's see, 0.2024, and then I'm just going to go ahead and make this into a negative 0.008, and then multiply that times 40. So this is one way to do that. Notice that we did do some rounding off, and so this is a rounded off answer, which may or may not be so good. But here's another way to do it. Remember that you stored your regression equation when you did the linreg t-test. We stored it into y1. So if we check y equals 2, this big mess over here is your actual regression equation, and it's accurate up to as many decimal places as the calculator will hold. So given that, I think it'd be a lot easier to use that regression equation. So back to the home screen, and we just did this calculation. Let's compare it to actually using that equation that we stored into y1. So remember how to get y1. Go to vars, yvars function, and y1. And then in parentheses, you're going to input your independent variable. So y1 evaluated at 40 is what this is saying. You press enter, we get 1.6960. That's fairly close to this 1704 that we got, but this is more exact, so I would go with this calculated work over here. So I'd say 0.1696 would be your cost per ounce. And I want to re-input almost the same thing. So I'm going to press second function and entry. This is another little shortcut. And I can right arrow to my last input and change just one or two numbers there. I can use delete or insert if I need to. So this one is y1 of 90. So let's press enter to get our answer for that, which is 1286. So given that, now we have given that we have 2 points that we can plot in our graph. Let's see if we can do this. I'm going to take out those excess lines that I didn't need. So this is back to our original scatter plot. And let's plot. Also, these markers are hard to see, but if I look at the point from the original data, I have 200 here and I have 64 here just as a marker, and I have 0.055 here that lines up with this point, and this goes all the way up to 0.249. So really hard to see and visualize. Whoops. Let's do this in green to try to draw this line. So we have the point 40. Let's see, 40 is over here even. So somewhere over here, 40. And 1.169. Let's see, 0.156 is over here that matches with this point. So 0.619 is a little bit higher. Six or 1696 is what we have. So that would be a little bit higher than that. And we have 90, so 100 is somewhere over here in the middle, so probably a little bit less. It would be 100 or 90. And then 0.12, so 0.12 would be a little bit below here. So So these are the 2 points, and then your graph would look something like this. Kind of hard to draw, but you can use your calculator. Remember that your regression line is already here, and you already did a zoom and zoom stat. So let's do that again. Zoom and zoom stat. And here is your line. And then if you trace this, hit trace, but I'm looking at my upper left hand corner of my calculator that says P1. That's the plot 1. If I press the up arrow, I see my Y1 equals to this regression line that I had for part D. And so I can trace that, and the best way to trace this, instead of just using the left and right arrows that I'm doing now, to be more accurate, I can just type in the actual input that I want, which is 40, and I can see where that point is. It's right a little bit above that point, which is what I drew over here. And then I can also press, for the second point, press 90, and that goes right over here. And so it's fairly accurate from what we drew on paper. Alright, so does it appear that the line is the best way to fit the data? Why or why not? It looks like based on our hypothesis test, it doesn't look like it is. Because we didn't show correlation. Alright, the next question, let's just say no here. Not linear. Question J, are there any outliers? And the outliers are defined to be the points that are far away, and the general rule of thumb that they ask is 2 standard deviations. So what is the standard deviation for this? If you remember the linreg t-test that we took, we can take it again. So let's go to stat, test, linreg t-test, and the same parameters that we had before, and calculate. So if we scroll down, we're going to note that for our S, our standard deviation, it's actually the standard error of estimate, is 0.06. So let's make a note of that, and let's find the distances from each of these points away from the line. I didn't draw this line all the way through, but we can take a look at that. So one way to do that is to go to your list again, and remember that L1 are your X values, L3 are your Y values, L2 is not significant here. I'm going to go to L4. Let's see. Let's get to L4. I'm going to go to L4, and I want L3 and L4 in the same screen. Let me clear L5 out just to make it a little bit cleaner. So in L4, what I want to do is I want to put those X values into the line equation. Now my line equation, remember, is in Y1. So while my cursor is up in L4, I'm going to press second function. Nope, sorry, not second function, just vars. Y vars function Y1. So my L4 is equal to Y1, and then into Y1 I want to evaluate it with my X values, and my list of X values are in L1. So if I press enter, here are the Y values that I have when I put it into the line. So that means for the first point over here, this X value is 0.06, 0.189, this x value over here, this x value for the third one is 0.1499, and so those are the two values that I'm going to be watching out for. So to find the difference between them, I'm going to go to L5 and I'm going to subtract L3 minus L4. Now when you subtract, sometimes it'll be positive, sometimes it'll be negative, and so what I'd like to do is just ignore the positives or negatives. So I'm going to say L3 minus L4, enter, and here is what I get. So these are called residuals. These are my residuals, and I got a 0.06. So by the way, if we take our standard deviation and 2 times the standard deviation is 0.12. So if anything is bigger than 2 standard deviations away, then I would probably consider that as my outlier. And if I look down here, it looks like the first one is 0.06. It's about 1 standard deviation away. This one is less than 1 standard deviation away. This next point is about 1 standard deviation away. Ooh, this last one, yeah, that's also less than 1 standard deviation away. So based on the data and our criteria, these distances over here, 0.06, this one is 0.02, this one is 0.05, and this distance over here is 0.016. None of them seem to be significantly far away, so we would just have to conclude based on our criteria that there are no outliers. Alright, so K, is the least squares line valid for predicting 300 ounces? For that one, we'd have to say no, because our data goes from 16 to 200, and anything outside of that would be an extrapolation, and in our extrapolation, we don't usually like to do extrapolations with the least squares lines. So let's just say no. And then for the last one, L, what is the slope of the least squares line? Slope is equal to that number next to the x, so that's a negative 0.0008. And interpret the slope. The slope is going to be the change in the cost. And the change in the cost per ounce. As the size increases. So that is the mathematical way of interpreting the slope, and the way to relate that to the problem is to use the specific variables that they have. Alright, so this is a long video. It has a lot of information. Feel free to rewind and move the cursor back to a point in this problem that you might have not understood or have gone too fast on. And I hope this will help with your homework.